learners, today we are going to solve chapter number 13, surface areas and volumes of class 9 IMO workbook of MTC publication. First section is of mathematical reasoning. Question number 1 is, if the height of a cylinder is doubled, by what number must the radius of the base be multiplied so that the resulting cylinder has the same volume as the original cylinder? We are just going to let the original cylinder's radius be R1, original cylinder's height be H1. So its volume, as we know that the volume of cylinder is pi r square h, so its volume will be pi R1 square H1. Now we are doubling the original cylinder's height to get the new cylinders. So 2 into H1. Both the cylinder is having the same value, so we can make an equation like this, that pi R1 square H1 is equals to pi R2 square 2 into H1 as it is given, and we have to find out the value of R2 square. So from here we get R1 square is equals to pi R2 square pi R2 square. Now from here, in this point, what we are going to do is cancelling pi. H1 is cancelled by H1, so 2 is left, R2 square and R1 square is left. So we are writing like this, that R1 square is equals to 2 R2 square. From here we get the value of R2 is equals to 1 upon under root of 2 R1. So the answer is 1 upon under root 2. Metal sheet 27 cm long, 8 cm broad and 1 cm thick is melted into a cube. Find the difference between the surface area of two solids. So there is one cube, and originally it was of, there is cylindrical metal sheet. No, it's not cylindrical, it's just a metal sheet. So a metal sheet is there, thickness is something given, and it is melted to form a sheet. So from here we know that the volume of this metal sheet would be 27 into 8 into 1, which is equals to 216 centimeter cube. Now we can find the surface area of the metal sheet. What would be that? That would be 2 into 27 into 8. 2 into 27 into 8 plus 8 into 1 plus 1 into 27. Applying the formula of volume and surface area, which is there in your book, you can see in your foundation books also. What is the formula? 2 into LB plus BH plus LH. We had applied this formula to find the volume of cube, and this is the formula of finding the volume of surface areas of cuboid. So what you are going to do is just add it all. So we get the surface area as 2 into 216 plus 8 plus 27. We get the surface area as 502 centimeter square. This was not needed, volume 502 centimeter square. Now volume of cube is equals to volume of metal sheet. So we know that the volume of metal sheet was 216, so it should be equal to the volume of cube, and the volume of cube is side cube, right? Now from here we get the value of A, that is side, because this is the cube of 6, so we can say that A is equals to 6. Now the surface area of cube would be 4 into would be 6a square, so 6 into a square, which is equals to 6 into 6 square, which is equals to 6 into 36, which is equals to finally 216. Now finding the difference, we had find that 502 centimeter square, and this is 216 centimeter square as we got it. So the answer is 286 centimeter square. Option number D. Next question is, if the height of a cone is equal to its base diameter, then its slant height is. That the formula of slant height of the cone, we can represent it by L is under root of h square plus r square. Now in the question it is saying that height is equal to the base diameter, so and the height is equal, so height of the cone is equals to diameter, that is 2r, so we can write instead of height 2r square plus r square under root, so we can write it as 4 under root 4r square plus r square. We get it as under root 5r square. We can write it as under root 5r. So option number here B is correct. Next question is, the length of the longest rod that can be kept in a cuboidal room of dimensions 10 meter into 10 meter into 5 meter. So length of the longest rod, so if we say that is a cuboidal room, so length of the longest rod would be the diagonal of the cuboid, and we know that the diagonal of the cuboid is root under L square plus B square plus H square. Putting the values, under root 10 square plus 10 square plus 5 square, we get it as under root 100 plus 100 plus 25. We get it as under root 225, and 225 is the square of 15, so the answer is 15 meter. Option number C is correct. Next question is, a hollow cylindrical pipe is 28 meter deep. Its outer and inner diameters are 12 cm and 8 cm respectively. Then we have to find the volume of the copper used in making the pipe. It is a case of hollow cylinder. Just try to understand the question. This is a cylinder. Okay. And some copper is used for making this is used in making this pipe. Inners, you can from viewing it from the top, we get the diameter as 12 centimeter, and of the inner the diameter is 8 centimeter. So we have to find the volume of copper used. Outer radius would be 12 divided by 2 because it is diameter, so we'll get it as 6, and inner radius be 4 because we are dividing it. Now height of the cylindrical pipe is given as 28 dm, so we have to convert it into centimeter because all the units are in centimeter, so we can get it as 28 into 10, 28 280 centimeter. Now applying the formulas, volume of copper used is simply pi into r square minus small r square into h. Not getting the formula? This is pi 22 by 7. R square is the radius of outer circle, or you can say whole circle, whole base. So we had find it as 6 square. So 6 square is we have to square the 6, that is 36, minus inner square, inner radius square, that is 4 square 16, into height is 280. Now we can see that 22 by 7 into, it will get it as 20 into 280. We can just cancel this by 40 times. So 22 into 20 into 40, this will become 800 into 22, which is 176 and 00. So 17,600 centimeter cube. Option number 1 is correct. Moving on to question number 6. The volume of a cylinder of radius R is 1 by 4 of the volume of a rectangular box with the square base of side x. If the cylinder and the box have equal heights, what is the value of R in terms of x? So the volume and volume of radius R is 1/4 of the volume of a radius rectangular box with a square. So let the height of the cylinder and rectangular boxes be h. And what we have to express is R in terms of x, h. So the volume will become, volume of cylinder is pi r square h. Now volume of rectangular box would be x into x into h, right? L into b into h. So the volume of rectangular box would be x into h, that is x square h. Now according to question, volume of cylinder is 1/4 the volume of rectangular box. So volume of cylinder, it is the volume of cylinder, and this one is a volume of cuboid rectangular box. Now volume of cylinder is equals to half, 1/4 of the volume of rectangular box. So we can write it as volume of cylinder, we have get it as pi r square h, and 1/4 pi r square h, which is equals to 1/4 pi volume of rectangular box, that is x square h. Now we have to just cancel out the things which are going to be, and rest of the thing is going to be okay. H is cancelled out by h. What we are left is, we have to r square is equals to 1/4 into x square and into 1 upon pi. I am rubbing the upper part so that I can write it. So from here we get the value of r square as 1/4 into r square is equals to 1/4. Here we can write it as pi and x square. So the we can cancel the things and get as r is equals to x upon 2 pi r, right? X upon 2 pi r. Why this answer? Because we had did one thing, that here is square, so under root will go over that. So 1 upon x square upon 4 pi में हम we are going to put under root. So x square will come out and 4 will come out, so only a pi will be there in the under root. So option number 2 is correct. Next question is, the edge of a cube is 20 centimeter. How many small cubes of as 5 centimeter be obtained from this cube? Volume is going to be the same, so let the n number of cubes be formed from the given cubes. So volume of big cube is equals to volume of n number of smaller cubes. So we can write it as volume of cube. What is that? A cube, right? So A, let the value of A be 20 centimeters. So we can get it as 20 into 20 into 20 is equals to n number of 5 into 5 into 5. So from here we get 20 into 20 into 20 upon 5 into 5 into 5 is equals to n. We can cancel it like this, 4 times 4 times 4 times. So 4 into 4 into 4, that is equals to 64. Option number 3 is correct for this question. Next question is, the volume of two spheres are in the ratio 216:125. The difference of their surface areas if the sum of their radii is 11 units. This is a very good question. So let the radii, that is radius r1 and r2, be the radii of the two spheres. According to the question, it is given that 4/3 pi r1 cube, because it is the volume of sphere. Now it is being said that we have to divide it by pi r2 cube. Then we will get the ratio as 216/125. Now we see that we can cancel both these things, and what is left is r1 cube upon r2 cube. So r1 upon r2 whole cube we can write like that is equals to 216/125. I am rubbing the front part so that I can write. From here we can move this cube as under root cube. So r1 upon r2 is equals to cube root of 216/125. So as we know that it is a perfect cube, and r1 upon r2 is equals to 6/5. Now from here we get that r1 is equals to 6 and r2 is equals to 5. The question is not ended here. We have to find the difference of the areas. And what is the area of the, and we have to find the difference of the surface areas. Surface areas are 4 pi r square. So 4 pi r1 square minus 4 pi r2 square is what we have to find. That is 4 pi r1 we have got as 6, and its square is going to be, or we can write like this, simplifying the equations, like taking the common 4 pi r2 square. 4 pi we will take as common and get r1 square minus r2 square. That is 4 pi r1 square. r1 is there like 36, because 6 square is 36, minus r2 square is 25. Difference is 11. 4 pi into 11. So 44 pi is the resulted answer. 4 pi square units. Option number D is correct. Next question is, the radii of two cylinders are in the ratio 3:4 and their heights are in the ratio 6:5. The ratio of their curved surface areas is. For this question, we have to let R1 and R2 be the two radius of the two cylinder. So R1 upon R2 is equals to 3 upon 4, and heights are in the ratio H1 upon H2 is equals to 6 upon 5. So we have to find the ratio of the curved surface areas. What you have to find is S1 upon S2, and what is its value? I am writing it on the upper side. 2 pi RH is what we say the curved surface area, right? Two pi R1 H1 upon 2 pi R2 H2. I am writing it once more. S1 upon S2 is equals to 2 pi R1 H1 upon 2 pi R2 H2. So from here we get R1 H1 cancelling both these things, pi R1 R2 into H1 H2, that is 3/4 in upon 6 into 6/5. We can just cancel what is cancelling, like 2, 3. So 3 3s are 9, 5 2s are 10, 9 upon 10. Option number 3 is correct. Next part of this chapter will come in the next video. Bye bye.